Hey guys, welcome to Deep Dive Coding. Today we solve LeetCode problem of the day, and this is a medium difficulty problem, and problem is minimum removals to the balance the array. So in this video I will explain first questions, then simulate the test case, and I will give you the two approach. For each two approach, first one is I will giving you to the binary search, and another one is sliding window. In each approach I will give you the intuitions, then build the algorithm, code explanations, and finally complexity analysis. Similarly, for the second one, for using the sliding window, I give you the intuition, build algorithm, coding explanations, and complexity analysis. Now without further delay, let's start the video. So basic question is given. So we are given two things. First one is nums array, that is an integer array, and another one is k variable. And what we have to do, we have to balance the what there is given a task. We have to do the balance the array. So balancing conditions is also given in the question. That is minimum element into k greater than equal to maximum element. That means if you multiply minimum element with k, this variable is given over here k, and that should be greater than or equal to the maximum element. That means maximum element can go at max at k times of minimum element, not more than that. So now we have few operations to do to convert that array balance. So we can delete any element in the array. So what we have to give the output, minimum deletions to convert the balanced array. That means let's say this is the array is given, and there are few elements over here, and we have to delete. We can perform deletion operations. By the deletion operations, we have to convert this array as balanced according to the condition. But that deletion should be minimum, so that we have to delete minimum number of elements to convert it balanced array. That is our main task. Now let's simulate the test case. So over here it is given 215. So which elements you delete? Let's first calculate whether it is already balanced or not. Minimum element of these 215, minimum element equal to 1, and over here maximum element equal to 5. So 1 into k, that means 2. Is it greater than or equal to 5? No, it's not. So this is not a balanced array. So what we have to do, we have to delete delete elements. Let's consider this way. So yeah, we just rearrange this thing in sorted way, 1, 2 and 5. So now let's delete first element. So we have 2 and 5. Now 2 into 2, this will give you the 4. Is it greater than or equal to 5? No, still it is not. Now delete 2 also, and 5 single element is also a valid balanced array. But if you delete this way, let's say we initially have 1 to 5. If we delete 5 instead of 1, so it will give you minimum element cross 2. Is it greater than equal to maximum element, that is 2, and this is correct. So over here we are just deleting one element, so 1 is the valid answer. Now come into the second test case. This one is given 1629. So let's rearrange this way so that we get 6 and 9. So if we want to delete, first let's check whether it is already balanced or not. So minimum element over here, it will be 1, and maximum element equal to 9. Now 1 into k, is it greater than or equal to 9? That k value is 1 into 2 greater than equal to 9. No, it's not. So this is not balanced array. Now we have to delete the few elements so that it will convert it to the balance. Now let's delete the 9, just random deletions. I'm not using any algorithm. Now you can, if you do this 1 into 2, it will give you the 2. so it is not greater than equal to 6, so 6 also not there, so this is not also valid. Now delete the 6. So again you perform the same, so it will give you 2. Is it greater than equal to 2? Yes, it is greater than. So 1 and 2 is a valid balanced array. Now let's delete from the first. If you so over here you are saying that you are deleting 2 elements. Now let's delete from the first element. So it will be like, let's delete the first one, that is 1. Now minimum element is 2, and 2 cross 2 it will give you the 4. And is it greater than or equal to 9? No, it's not. So now let's delete the 2 also. So now minimum element is 6. Now 6 into 12, 6 into 2, it will give you 12. Is it greater than equal to 9? Yes, it is. So it is a valid answer. So over here it's a balanced array, and we are deleting 2 elements. So minimum element to delete is 2. I think you almost get it. Now let's consider this one, 4 and 6. Minimum element over here is 4, and max element given as 6. So if you consider this way, that 4 into k, that is 2, it is equal to 8, and is it greater than or equal to 6? Yes, it is greater than equal to 6. So we do not need to perform any operations. This is already balanced array. As we did not delete any element, so output is 0. So I think you get the answer correct. Now come into the solution part. Now we have the 2 solutions approach. One is binary search, another one is sliding window. For binary search, I will give you the intuition part. Now, so over here you already seen that what we can do, first of all we have to sort the array so that we can get the correct window properly. That means we do not need to if we sort it this way, like non-decreasing fashion. So if you consider this element as a first, I will give you the intuition part. Okay, let's give an example. Let's 1, 2, 6 and 9, it is sorted array. Now let's consider this element as the first starting index. You can say this is the start element. So if it is the start element and it is the minimum element, and if you converted this minimum element, that is mean element, into k, should be greater than equal to max element. That means 1 into 2, over here it is given 2, right? Let's check. Yeah, it's k equal to 2. Okay, so k equal to 2 over here. So if you do these operations, it will give you 2. So maximum possible element can be 2. So you can find it, here is 2. So there are 2 elements. This much portion is valid balanced array. So we have to delete these 2 elements. Now if you consider from the second, let's say 6 and 9, and you consider this element as the first element, so you already delete this element and you consider this is as minimum element. So if you do this operation 2 into 2, it will give you the 4, and we have to delete this also, because so only one element is the valid balanced array. So over here we are giving we are deleting the 3 elements. Now consider this one also, 6 and 9. We just want to start from the 6. So we have already deleted 1 and deleted 2. Now take it this way, 6 into 2, this will give you the 12. Is it greater than equal to 9? Yes, it is greater than. So this is the valid balanced array, and we are deleting the 2 elements over here. And you can consider this, as I already get the, now you can consider this also, 6, 9, and we delete 1, 2 and 6. We only have the 9 element. So this is a valid balanced array. So over here 3 elements already deleted. Now let's try to do the operations from the backward, like 1, 2, 6 and 9. Let's first delete the 9th element. Let's start the operations considering 9 as a last element. That means maximum element already fixed, maximum element equal to 9. We just need to calculate what is the possible minimum element. that will you can get it by this way, that is possible minimum element equal to you can say this function greater than or equal to maximum element by k. That means to get the minimum element, unit is greater than or equal to 9 by 2, so it will give you almost 4.5, and minimum element should be greater than or equal to 4.5. that means if you consider 9 as an last element, so greater than 4.5 is the 6, you can get this is the valid balanced array. And if you delete similarly, you can also delete 9 and you can consider 6 as a last element, and also you can delete 6 and 2 as a last element, you can delete 2 and 1 as a last element. So this way we can fix let's say this is the start element, and we try to find the answers for the last element, what is the possible index of the last element. Or we already fixed for the last element, let's say this is the last element, you can say the first start element 1, last element 1, and you can say last element 2, we fixed a last element, then we can find that what is the possible start element. By this way you get the valid range, like if you get this answer, so it will be the valid range. Once you get the valid range, and if you subtract from the total elements, like n minus considered element, let's say considered element, that will give you the total number of elements to delete to convert that valid range. So we just have to find the, if we given, we have a one task, like two tasks actually. If we given a start element, so we need to find the last element, and if we give the last element, we just need to find the start element. So how you can do these things, like you know the range of the start and last element when it's come in the calculation part. So as array is already sorted, so you use the binary search to get the answer, like find the where it is the indexing. So I will discuss this part in the algorithm. Now let's come in the algorithm. First we have to sort the nums, that is array, in the non-decreasing fashion. That means either it is increasing or it is flat, not this way, this is not valid. Okay, it can be this way. And now we iterate for each index 0 to n minus 1. We just considering let's say this is the array, there are few elements over here, and we considering the we are traversing each element. You can say consider this is an I, which is given an index 0 to n minus 1, and consider it as minimum element. That means where one condition is we are starting from over here, and another condition is we are ending over here. That means this is the starting, that is considering this is a first minimum element, and if it is considered the first minimum element, then we have to find the last element which is in the which satisfy these conditions, that is less than or equal to nums index into k. We can do these operations using the upper bound, and I will explain the upper bound also in upcoming slides. And another condition is consider this is as the last element, that is maximum element. So if it is maximum element, then we have to find the minimum element, that will be the first element. Like we have to find the first element, we are considering current element is the last element. So it can be done using these operations, that is greater than or equal to nums index by k, as I already discussed over here, that how we get the answer over here. So now, and we also find this index using the lower bound, and after we get all these valid range, we just subtract from the n, so that we get the number of deletion part, and we update the global minimum accordingly. So this is the algorithm. Now let's come in the lower bound part. So what is lower bound? So lower bound and upper bound similar functions is also available in Java and Python, so you can check it, that also work in the similar fashions. So I will give you the overview of the lower bound and upper bound. So lower bound finds the first positions where an element greater than or equal to, just consider this, greater than or equal to the given value in the sorted array. That means let's take an array that is 2, 4, 6, 8 and 10. We just want to find the value of 5, so it will check where this 5 can be inserted in the sorted array. So if you do this way, the sorted this 5 can be inserted over here. So lower bound return the positions of the 6, that means it will return the second index. This is index number 2, and yeah, so if this this way, let's say it can be 6, 6, 8 and 10, and if you are searching for let's target equal to 6, so it will give you this value because this is the greater than or equal to other. And if you looking for the value 7, and it will give you the 8th positions. This will simply return the lower bound functions, and this time complexity is log n time complexity because this is use binary search, or you can use your lower bound functions using the binary search also. And now let's come into upper bound. Also give the first positions where an element greater than value in the sorted array. In the lower bound case, there is greater than or equal to, and in the upper bound it only greater than, that means strictly greater than from the value. That means let's say we are given 2, 4, 6, 6, 8 and 10. If the target is 6, so it will simply return the positions after 6, that means these positions is returned. So if you can consider 0, 1, 2, 3, 4 and 5, it will return the positions at the 4th index because this value is greater than 6. So this is the upper bound case. Now let's come into the coding part. As I already discussed the algorithm, accordingly I give the coding part. So first let's sort the array. Now let's define a global value for the minimum delete that will consider as infinity. You can consider we are initializing as infinity. You can say int max for the integer, and n equal to nums dot size. Now for index, we traversing from 0 to n minus 1, and each index we considering the two things. First, this one considered as first element is the current element, and over here it is the last element as the current element. So minimum deletion, min delete equal to min delete comma this function and these functions, and these are the functions will return if it is the first element. So we just return this value is true, and if it is for considered as the last element, we just return false. And I will explain this cal number delete functions also. We just pass and it will give you the range, like number of deletions required to convert that array, considering index as first element, and over here considering index as last element. And at last we just return the min delete variable. Now if you consider these functions cal number delete, so it will return, it will take few arguments. First of all index, then nums already taken as constant because we are not changing over here, and another main important thing is boolean is from first. That means it's take, if it is true, then it will consider that index value is the first element. If it is false, then it will consider this is the last element, and additionally k is taken. So it will also take the n as num dot size, and if it is from first, that means if it is true, then we are deleting the considering index equal to first element, and in these portions index is taken as last element, like considering last element. If index is the first element, we have to find, so we can say treat the num index as minimum element because it's first element, that is the minimum element. Now we have to find the as maximum element as possible so that the range is maximum, so the number of deletions is less. So just let's find the element where nums of index into k is element greater than nums of index into k. So let's define the target, which is nums of index into k. Now apply the upper bound operations, so it will give the iterator of that position. So nums dot begin plus index, we are starting from the index until the nums dot end, and we are providing the target which it needs to search. Now it will and distance will keep the distance of nums of index, nums dot begin plus index and iterator. So it will simply calculate the distance between iterator, whatever written over here, and the nums dot begin plus index, and at last we just return n minus elements of kept. Similarly, we are using same thing over here. So minimum allowed we are using double because it will give you the fraction. So nums of index by k, and we just calculate using the lower bound. We will pass this nums dot begin plus index plus 1. We are considering the value, let's say this is the nums. So in the second operations, and we are considering this is the last element, and for the lower bound we are just giving this from there here to here, and last element is not considered, so we are just passing the value plus 1. Also, and which value to search, so we are given that minimum allowed, and it will give the distance between the iterator, which is written over here, and nums dot begin plus index plus 1. It will give you let's consider this is the iterator pointing over here, and this distance functions will calculate the distance from this portion, and as the given the like range, so if we subtract from the total number of elements, it will give you the minimum number of deletions required to convert that array balanced. I think coding part is clear. Now let's jump into the complexity part. So complexity, you can consider this sorting algorithm which takes big O of n log n complexity, and we are going through this of n times. So big O of n for each, this one will takes big O of log n, because we are using, and this one also take big O of log n. I will explain why. And combining, you can let's consider why it's log n. So if it is, whether it is from first or second, we are using upper bound is the main functions and lower bound over here. So these are the two functions used. So it will take log n because it use binary search. Over here it will also take big O of log n time complexity because this also use the binary search. So you can consider the total time complexity as, so time complexity so it will give you the first of all this one in log n for sorting, and big O of n into big O of 2 log n, because for each index we try to perform 2 search, considering that is first and also considering that is last. So you can consider this will be big O of 2n log n time complexity, or you can consider this is as big O of n log n time complexity. And for the space complexity you can consider, let's check it where what are the spaces is required. So we are taking the mean deletions, this is constant, and over here we are not taking any extra space to compute. So you can consider this is the constant space complexity, or you can consider as big O of 1 space complexity. Now come into the second approach. This is the sliding window approach. So this is also a very intuitive approach. So intuitions behind this is simple, like we already defined the array is sorted. Now for any valid subset satisfy the below conditions will always be the segment. What is the condition? So maximum element can go as max as k times of minimum element. What it mean? Let's consider this is as minimum element 1. For this minimum element we consider this is the possible maximum element. So let's capital ME1, this is the maximum element, and so capital ME1 is less than or equal to k times ME1. This is already valid. Now if you consider this is the next minimum element, let's consider ME2, so you can get that answers greater than or equal to ME1. Why? Let's consider this is ME capital ME2, that is maximum element, because as the minimum element is also increased, so if you you get these equations properly, like k times me2, as me2 is greater than me1, so if you multiply both sides with k, so it will be like k times me2 is greater than k times me1, and you get this one, like k times me1, this one, it can be same, capital Me1, it will be okay, let's sorry, it will be capital Me2 is greater than capital Me1. So that means capital Me2 is always be greater than or equal to capital Me1. This is an important statement, like capital Me2 is greater than or equal to capital Me1, because we are increasing in the small me1 to small me2. So using this, if we try to like if we iterate a small pointer, we are try to iterate the small pointer over in from left to right, and we also for this pointer we just calculate this is the maximum value possible. Let's say this is minimum pointer, and for this maximum value is possible. So when we increase that pointer to over here, so maximum pointer only have the directions towards the right, no towards the left. So you can consider this as a sliding window approach, sliding window, or you can say it can be a two pointer. Both are almost like, you can consider this as a two pointer because we are using two pointers, but actually we are dealing with the sliding window. That means what I want to say, we have an array, there are elements present. So let's start minimum element over here, and for this minimum element we just try to place a maximum pointer over here initially. Now as now we just for this minimum element we just place that maximum pointer as maximum as farthest as possible. Let's consider maximum pointer goes, this is the valid maximum pointer. So when we increase this minimum pointer to over here, so maximum pointer either stay in this same place or it will be in the rightward. So in combined way, minimum pointer iterate all elements exactly once. Also max pointer iterate all elements exactly once, this way, and it will not give you the n square time complexity. So now let's come into the algorithm part. First of all, we have to sort the array. Now take the end pointer that I already discussed. This is considered as maximum pointer, this is considered as maximum value and considered by like initializing as 0. Now iterate through the start pointer. So this is the minimum pointer, like minimum value pointer, and it go from 0 to n-1 like till the end of the array. And for each start pointer we just increase the end pointer as maximum as possible, and up to what is the conditions for over here, nums of end pointer should be less than or equal to k times nums of start pointer. That means is same conditions, that is max element less than or equal to k times of mean element. This is the conditions. Now once we place that pointer as max as possible, now we just calculate the difference, like end pointer to start pointer, it will give you the valid range, and if you subtract from that n, you get the number of deletions required, and we also update the global variable, that is minimum deletions, and at the last we just return mean deletions. And let's come into the coding part. I discussed the coding in the C++, but you get that Java and Python code I will attach in the descriptions, so you can look it, and these are the exactly same. So now for the coding is simple over here. So we just first sort the array in non-decreasing fashion and take the global variable that you can say mean deletions int max. You can considering it is as like initializing infinity. Now n equal to nums dot size and placing an end pointer end equal to 0. Now we start given a start pointer 0 to n minus 1, we just iterating for that, and for each start pointer we try to place as maximum as possible the end pointer. So n less than n, so this should be a valid range, and nums of start into k greater than equal to nums of end. This is the exact same condition, and as if it is true, then we just increase the end pointer, and at last we just calculate the distance n minus end minus start, and at last we just return the minimum delete variable. Now why we place long over here? So it is to avoid the integer overflow, like we are multiplications going over here. So if you consider this is the maximum int, and if it is key also the max int, so it will, if you multiply both of these, so it will give you the overflow, integer overflow. To avoid the integer overflow, we just use the long, so that it will be, the operations will be perfectly fine. Now I think its coding part is clear. Now come into the complexity analysis part of this version. So similarly over here we are doing the sorting, so it will be in log n time complexity for sorting, and we are iterating over here start pointer big O of n times, and you will say that end pointer also n times. No, it's, but the start pointer iterate n times and end pointer iterate n times, but all the start and end pointers each iterate each elements exactly once. So combining this loop give you the big O of n time complexity. So you can consider the total time complexity would be for n log n for sorting, and plus big O of n to iterate, like to do the sliding window apart. So it will give you the big O of n log n time complexity. You can consider it is a big O of n log n time complexity. Now for the space, we are not using any space, so it will be the like constant extra space. So you can consider big O of 1 space complexity. Thank you guys, thank you for watching. Stay tuned for more videos, and I will attach the notes in the YouTube descriptions, and please subscribe the channel if you like it. Thank you guys.